Hey, welcome back to your favorite technical mathematics class. We're going to look at logarithms today. So a logarithm is the inverse of an exponential. So for example, last time we did things of the form log base 2 to the x, and you had the points. If you plug 0 in, you'd have 2 to the 0 is 1, plug 1 in, 2 to the 1 is 2, plug 2 in, 2 squares 4, 2/3 8, and so on. And you plot all those points. Well, the inverse of a logarithm we're going to call log, and it's log base 2 of x in this case, because the original base was 2, so you use a base of 2 for the logarithm. And all those points just flip around. So instead of 0, 1, you're going to have 1, 0. 1, 0. Instead of 1, 2, you're going to have 2, 1. Instead of 2, 4, you're going to have 4, 2. And anyways, you could graph all these points, and this is a graph of your logarithm, okay? And it has a property here. If b to the x equals n, then log base b of n equals x. And the reason is, since they're inverses, that means the x's and the y's flip-flop. So x equals 2 to the y, okay? Or 2 to the y equals x. So here's how I remember it. Let me write log base b of n equals x. So that means this is the logarithmic form. The exponential form of a logarithm, the exponential form of the same logarithm, is b to that power, b to the x, equals n, if I'm going to stay consistent with your textbook. B to that power equals the number right there, n. Okay. So if you write these in exponential form, so 10 to the third equals 1,000. Let me erase some of this real quick. Actually, you know what? I'm going to do these next ones first, and I'll come back to those. I think it's easier to go this way. If the log form of this, log base 5 of 125 equals 3. If you were to write that as an exponential, you go 5 to that power, 5 to the third, equals the number right there, 125. That's how you do that. So the next one is 3 to the negative 5. 3 to the negative 5 equals that 1 over 243. 1 over 243. The next example says log of 100 equals 2. Now notice there's no base on this log. If it's blank, go ahead and write in a 10 right there. That means it's a base 10. And then do the exponential form. So you go 10 to the 2 equals 100. Of course, 10 squared is 100. That's the exponential form of that one. And then the final one right there, again, notice they did not put in the base, so write in a 10. And then do it. 10 to the negative 4 equals the 0.0001. Okay, so let's go back now to these problems. So we're going to go from exponential form. So right now it's 10 to the third equals 1,000. We're supposed to go the other way. So I'm going to write my log, and I'm going to write my equal sign. I'm going to go 10 to the third equals 1,000. There's the logarithmic form. Log base 10 of 1,000 equals 3. The next one right here, let me write the log and the equals. So 10 to the 4.6419 equals 0.6667. There's the logarithmic form. The next one, 5 to the negative 4 equals 1 over 625. I'm going to write my log, write my equal, and I'm going to go 5 to the negative 4 equals 1 over 625. There's my logarithmic form. Last one, 3 to the 4th equals 81. Write my log, write my equal. 3 to the 4th equals 81. There's the logarithmic form of the last one there. Alright, so this second set of problems at the bottom here, find the value of the logarithm without using a calculator. erase this other stuff. What you need to do is you need to take that log base 2 of 16 and you set it equal to a value. If we can find what x is, set it equal to a variable. If we can figure out what x is, we'll have found the value of the logarithm. So now use exponential form. So go 2 to the x equals 16. And then just think to yourself, solve this analytically. What would x have to be? 2 to what power is 16? Well, it's not 2 to the 1, because 2 to the 1 is 2. It's not 2 squared, because 2 squared is 4. It's not 2 to the third, because 2 to the third is 8. 2 times 2 times 2. But it is 2 to the fourth. Because 2 times 2 times 2 times 2, there's 4 of those, is 16. So x must be 4. In other words, log base 2 of 16 must be 4, because we found what x is. Let's do the next one, log of 1,000. Again, set equal to x. If they don't write the base in, you know it's base 10. That's called a common logarithm. If they don't write the base in, it's a common logarithm. It's base 10. Run the exponential form. 10 to the x is 1,000. 1,000. That's 1,000. There you go. What would x have to be? Well, x can't be 2, because 10 squared is 100. But 10 to the third is 1,000. 10 times 10 times 10. So x is 3. So in other words, log base 10 of 1,000 must be 3. And that's how you're going to think about these. Log base 4 of 64 is the next one. Set equal x. Solve for x. 4 to the x is 64. Well, 4 times 4 times, how many 4s does it take? Well, 4 squared is 16, but 4 to the third, 4 times 4 times 4 is actually 64. So again, x is 3 in this case. So log base 4 of 64 must be 3. Okay, this last one here, log, notice they don't write the 10 in, is 0.00001. Well, that's 1 100,000ths. I'm actually going to write it 1 100,000ths. Log base 10 of 0.00001, in other words, 1 100,000ths, is x. So now I'm going to run the exponential form. 10 to the x equals 1 100,000ths. In other words, 0.0001. What does x have to be? Well, it can't be like 10 to the 2. It can't be a positive integer. Just 10 squared is 100. 10 to the third is 1,000. We're getting bigger. So we're going to take a negative integer. Try a negative integer. How about 10 to the negative 1? Well, it's not 10 to the negative 1, because that's 1 over 10 to the 1, right? It's 1/10. It's not 10 to the negative 2, because that's 1 over 10 squared. That's 1 over 100. That's not big enough. Well, 10 to the negative 3, that's 1 over 10 to the third. It's 1 over 1,000, but we're getting close. What is it? 10 to the negative 5. 10 to the negative 5 is 1 over 10 to the fifth, which is 1 100,000ths. So x is negative 5. That's what x has got to be right there, negative 5. So log base 10 of 100,000ths, 1 100,000ths is negative 5. All right, so use a calculator to find a common logarithm around 4 decimal places. So just find your log key. Notice that these are all common logs right here. They're log base 10 on these. There's no base, so you can just use your logarithm key, or if you want to, you can pull up decimals again. And you just punch it in, log of 0.0327, log 0.0327, enter. You see how you get it right there, negative 1.4854. The next one was log of 120. You get 2.079, 18, and so on. Okay, so that's how you think about those. That's how you can punch those in. find the value of the variable on this next part. So log base 4 of 16 equals x. So you're going to go ahead and solve for x. So 4 to the x has got to be 16. X has got to be 2 because 4 squared is 16. So x is 2. Find the value of the variable in the next one. Log base 5 of 125 equals x. 5 to the x equals 125. 5 to what power? Well, 5 to the third is 125. So x is 3. Next one, now you notice the x is in a different position. Log base 7 of x equals 3. Put it in exponential form. 7 to the third equals x. 7 times 7 times 7. 343 is what your x is. Fourth one there, log base 16 of 1/4 equals x. So 16 to the x equals a fourth. This one's a little bit tricky, especially if you haven't seen this one before. So you try some positive integers, they don't work. You try some negative integers, they don't work. But you do know that the square root of 16 is 4, but you got to get the 4 on the bottom. So the trick on this one is to a negative 1/2 power. Because that is 1 over 16 to the 1/2. And 1/2 exponent means the square root of 16. See how that's 1/4? So x has got to be negative 1/2 on this one. Next one, log base b of 81 equals 2. B squared is 81. What does b have to be? Well, b's got to be 9, because 9 squared is 81. So b is 9. Last one, log base b of 5 is 1/2. So b to the 1/2 equals 5. In other words, the square root of b is 5. Well, what's b got to be? The square root of what is 5? Well, we know the square root of 25 is 5. So b is 25. Use a graphing utility now to graph the following. So let's go back to Desmos here. Let's clear these out. We're going to graph y equals 3 times log of x. And you get the graph here. You got the 0.10. You can plot some other points if you want to with your, you can start at whatever you want. Notice the -2 is undefined, but anything to the right of 0 you can plug in. And you can do 1, do 2, do 3, 4, and so on. Anyways, plug in whatever you want on these. Okay, so that's 3 times log of x. The next one is y equals negative log of 2x. Oops. Y equals negative log 2x. So there's your graph on that one. Again, you can zoom in and out with this and play with it on your graphing utility and then select the proper choice in the homework. Okay. Alright, so an application with logarithms. The Richter scale measurement is a measure of the magnitude of earthquake of intensity I, and it's using this formula. I subscript 0 is the minimum base level. Find the Richter scale of the 1906 earthquake where this is your I that you're plugging in. So what's the Richter scale measurement if you plug that I in? Well, the I on the top is 2.5 times 10 to the 8th times I subscript 0, and it's all over this I subscript 0. So I should have brackets right there. Notice the I subscript 0's go, so we're just left with punching this in. 2.5 log of 2.5 times 10 to the 8th. So now you just grab your calculator, punch this in, and this ends up being 8.4. So Richter scale of 8.4 was that 1906 earthquake. Well, thank you for listening and learning about logarithmic functions. See you next time.